Could ice volcanoes explain Ceres' missing craters? Dwarf planet puzzle scientists. Sometimes it's what's missing that really stands out. Scientists using data from NASA's Dawn mission have found that the dwarf planet Ceres seems to completely lack any giant impact craters, even though it has plenty at smaller sizes. The findings, described in the journal Nature Communications, hint at certain geological forces on and within Ceres, perhaps cryovolcanoes or the viscous relaxation of surface ice, that could shed light on the little world's internal evolution. On people and on planets, scars have stories. On worlds we can't visit every day and study up close, craters are incredibly useful. The shape of a crater may indicate what type of rock lies on the surface. The debris thrown up by the impact, known as ejecta, can reveal the composition of rock beneath it. Those craters can act as geological timekeepers too. Researchers use the crater abundance to date these distant worlds, from Mars and the Moon to dwarf planets and asteroids. Generally, the more craters a body has, the older it probably is. Size matters too. There should be a certain distribution of small, medium and large craters in the count. Ceres, the largest member of the asteroid belt that lies between Mars and Jupiter, should be no exception. Scientists think asteroids were the leftover building blocks of planetary formation, and so we can learn a lot about what the early solar system looked like by studying them. Ceres is particularly interesting because it's so big. At nearly 600 miles across, this large body for some reason never managed to collect enough material to make it to full planet status. Understanding it in depth could reveal a lot about our solar system's early history. One of the ways to do that would be to study the craters on its surface. By virtue of its large cross-section and ancient formation, the study authors wrote, Ceres offers a unique opportunity to study the earliest and most violent phase of collisional evolution by sampling craters whose sizes can largely exceed those on any other asteroid. Here's the weird thing about Ceres, though. Those large craters seem to be completely absent, which doesn't make sense, since the dwarf planet should have been subject to the same rate of impacts as the belt's smaller denizens. According to collision modeling, there should be around 10 to 15 craters with a diameter greater than 250 miles on the icy dwarf planet. And based on the cratering on fellow oversized asteroid Vesta, which the Dawn spacecraft visited before heading to Ceres, there should be 6 to 7 of these enormous impacts. By either prediction, several enormous craters should mark the surface today. And yet none can be seen. The largest documented impact craters on Ceres are much smaller than 250 miles. Kerwan 173 miles and Yalode 167 miles. There don't seem to be any impact basins larger than 175 miles or so across, and in fact, craters over 62 to 93 miles in size are what the authors called severely depleted. What explains this? The researchers scratched their heads. Perhaps Ceres did not start out in the asteroid belt but migrated there, a theory supported by the presence of ammoniated phyllosilicates on the dwarf planet. But even with a fashionably late arrival, it should have a few large craters, not a total absence of them. After studying the surface, The scientists think that such giant impacts did happen, but the evidence has been erased over time. They even identified one, possibly two 500-mile-wide basins that might have been the result of massive impacts, most notably one called Vendimia Planitia. The overall shape of Vendimia Planitia's topographic profiles resembles that of the comparatively well-preserved Kerwan crater, if one takes into account minor post-formation evolution due to relaxation, the authors wrote. Overall, this depression is the best candidate for a large crater recognizable on Ceres' surface. It's still not clear exactly what erased such a giant impact crater, if it or they did indeed exist. It's possible that the ice on Ceres relaxed, smoothing out what the study authors called long-wavelength features, like the dip over many miles of a large crater basin. Short-wavelength features, like the sharp ridge of a crater rim, would not have been wiped out by this particular process but could have been obscured by many later, smaller impacts. It's also possible that Ceres was resurfaced by stuff spewing out from ice volcanoes, which could explain the high peak of it or the mysterious bright spots in a crater. But the scientists said they have yet to see any float features on the dwarf planet's surface. Finding the answer will take much more study. But in any case, it seems that the crater's absence might tell us just as much about Ceres' insides as their presence would. Regardless of the specific mechanism for crater rim removal, our result requires that large crater obliteration was active well after the late heavy bombardment, the study authors wrote. This conclusion reveals that Ceres' cratering record is inextricably linked to its peculiar composition and internal evolution. Amina. Con at Latimes.